Playbooks are the building block of all the Ansible use cases that I mentioned previously, as we can now do configuration management, orchestration deployment, and provisioning all from a single playbook. Playbooks are written in YAML format and are structured using things called plays. There can be one or more plays inside of a playbook. However, today we're just going to start off with an example of one play. You'll see that I have a file ready to go called mariadb.yml. I'll just open that up and get started. To begin, we have our three dashes to start our YAML file. And then best practice is to name your play so that someone else coming in knows immediately what we're going to do in this playbook. I'll name mine install and configure MariaDB. Then we have our host declaration line. Just like with an ad hoc command, we can choose to target all of our inventory, target locally, target a group, or a single host. I'll continue as I did before and target the group name, which is test server. Then you tell Ansible which user you're going to connect as, which in this case is EC2-user. You don't have to specify it here if you've already specified Ansible underscore user in either your inventory file or in a VERS file somewhere. We can then decide whether or not we want to do root level operations on the target machine by setting become to yes. This is an example of privilege escalation, which we are going to talk more about in a future lesson. I'm also going to include a var section here because I am using a variable in my template file later. So I just need to indent a few times and then I'm going to set my SQL port to 3306. Now the next part of a play is the task section. Tasks are executed in order from top to bottom and they can be run at any time if a failure occurs. This again goes back to that principle of idempotency. If you get 75% of the way through the playbook, experience a failure, and then rerun, it's not going to execute those earlier tasks again. They'll just be skipped. Now, the only exceptions to this are the command shell and raw modules, but with the first two, you can add a creates flag to keep idempotency. So just like with our play header, we'll want to name our tasks. And my first task will be to install MariaDB, which I will do using the yum module. So yum, name of my package name, which is MariaDB-server, and then state equals latest. And then our next task, since this play is also about configuring, would be to push out a configuration file to our managed host. And for this, I would recommend using the template module, as we can actually access those variables we fact gathered using the setup command. In this case, however, I'm just using a standard configuration file with one variable in there for the DB port, and I will show that file in just a bit. So I'm going to name my task MySQL configuration file template module. Set the source equal to my.cnf.j2. The source is where the file lives locally on the machine running Ansible. And then the destination is where you want it to go. So my.cnf in the etc directory. And then I'm going to include a notify here to restart the service. So before I move on, typically when you push out configuration changes, you may want to restart the services if the file does change. And that's why I included this notify task. This is going to trigger at the end of the task block, and it's going to happen only once. So I can include multiple notifies that do the same thing, and it will still only happen the one time. Now, the task inside the notify is called a handler. Handlers are special tasks that only happen if a notify notifies them. In this case, MariaDB will not get restarted if there are no changes made to the my.cnf file. The important thing with this task is that we need to have a my.cnf.j2 file in the same directory as our main playbook since I didn't supply a path. Now, moving on to our third task, I need to configure the log file in order to get the service to start. And so for that, we're going to use the file module. And I'm going to provide a path to the file module, which will be var log mysqld.log. So that's where I want the log file to go. I'm going to create it with state equals touch. And then I'm going to do some permission. So I'm going to set the owner to MySQL, the group to MySQL, and the mode to 0775. So those are my chmod permissions of the file. So then our last task before we handle the handler is to start the service. For that, I'm going to use the service module and I'm going to give it the service name, state equals started, and enabled equals yes, which ensures that the service starts on boot. Okay, lastly, the handler section. So every time I have a notify in a playbook, I have to have a corresponding handler section so that the notify has something to notify. And in this case, I said that I wanted to restart the service. So I'm just going to do restart MariaDB, and it's pretty much the same as the service task right above, except I'm just restarting it. And just kind of taking a quick look, making sure my syntax looks okay. Great. So now I can actually go ahead and run this playbook. And before I do that, I did just want to cat this template file for you to see. It is a standard configuration file, and the only thing that's different here is the MySQL port is a variable, which I've defined in the var section of my playbook. So to run the playbook, I could do Ansible playbook, specify my hosts file, and then the playbook that I want to run, which is mariadb.yml. So I'll press enter. It's going to start off by gathering facts, which happens implicitly. Then it's going to install MariaDB, just like we specified in the playbook. And then once that completes, it's going to move on to the other tasks. So MariaDB has been installed. We have pushed out our configuration file and we have created the log file. And now all we need to do is start the service. Now the handler kicks off to restart the service. And once that's complete, then the playbook is complete. And as you can see, we've got okay on all 6 of the tasks that we have in here, changed on 5. And again, just going back to that principle of idempotency, I could run this again and then all of those tasks would now change to okay, and the handler would not even run because no changes were made.